Hi guys, so it's already 2 a.m. and I have some midnight cravings once again, so I decided to get some food. Now, I have here some black coffee and some blueberry cheesecake. Now, all of the food that we eat are all examples of mixtures. Mixtures can be classified into three, which can be a solution, suspension, or a colloid. Now, the black coffee that I have right here is an example of a solution. Meanwhile, the cheesecake itself, the parts of it can be classified into a suspension or a colloid. So the blueberry filling that is found on the top is an example of a suspension. Meanwhile, the cream cheese itself is made up of colloid. So what are mixtures in the first place? So let's try to find out in this episode of Science at Home. Hi everyone, welcome back to Science at Home, and for today we're going to be discussing the different chemical systems of matter, in particular the nature and classifications of mixtures. As you can see right here, matter can be classified as either a pure substance or a mixtures, in which pure substances include elements and compounds. Meanwhile, mixtures can be classified as either a homogeneous or a heterogeneous mixtures. Now, let us first try to differentiate what is the difference between the pure substance and mixtures. Now, pure substance, as you can see, is made up of the same kind of atom or molecule and does not have a definite composition. Now, in this case, for example, so we have the oxygen molecule, so it is represented by the red circles. So the red circles, as you can see, each oxygen molecule is made up of two atoms of oxygen. So that is why for every molecule represented in this diagram has two circles. Meanwhile, mixtures, on the other hand, are made up of different kinds of atoms or molecules and don't have a definite composition. Now, let us first try to explore what are pure substances, starting with elements. Now, in terms of elements, it is considered as the simplest type of substance with only one kind of atom, simply because that each element has their own distinct number of protons. Now, the number of protons for each elements are represented by their atomic number. So, take note as well that elements cannot be broken down into simpler forms. And we also have known 18 or 118 elements, which are represented in the periodic table of elements. Now, in the periodic table of elements, it can be classified as either a metal or a non-metal. So, metals include such as titanium or mercury, or it can be non-metals such as sulfur, and together with the other gases such as hydrogen and oxygen. Compounds, on the other hand, are made up of two or more elements bonded together. Now, as you can see on this example, so we have the table salt. So the table salt or sodium chloride is represented by two elements, namely the sodium, represented by the symbol Na, and chlorine, are represented by Cl. So take note as well that compounds can be broken down into simpler forms or going back to the element form, okay, through chemical means. But let us first have this example. Okay, so we have here two compounds that are made up of the same type of elements. Namely, so the H2O2 or the hydrogen peroxide and the H2O or the water. So H2O2 are made up of two atoms of hydrogen and oxygen, both of them. Meanwhile, water is only made up of two atoms of hydrogen and only one atom of oxygen. Although they have the same type of element, but they differ in terms of their number of atoms. So, therefore, what does it mean? So, the number of atoms for every compounds or for every element of the compound, rather, okay, denotes the chemical properties of each substance, in which hydrogen peroxide is usually used for as an antiseptic. Meanwhile, water can be used in many forms, and it can also be found within living things. Okay, going to the idea of mixtures. So, mixtures, okay, let us define mixture. So, it should be made up of two or more substances combined physically, and it does not have a definite composition. So, meaning it does not have a definite composition, meaning maybe one or two, or maybe the different parts of the mixture itself can have different amounts, varying. And lastly, it can be separated through physical means, since it was mentioned that mixtures can be combined physically. So let us now go first with the first type of mixture, which is the homogeneous mixtures. Now, homogeneous mixtures are also known as solutions simply because they are made up of two components, namely the solute and the solvent. So later we will going to be discussing what are those. So take note in terms of homogeneous mixtures that its particles are uniform in terms of its distribution and appearance. Therefore, it cannot be seen through the naked eye. And its particles are very too small to be seen because that some of the solute or most of the solute particles are dissolved within the solvent. Okay, so as I mentioned, let's have an example as the coffee. So the coffee grounds is considered as a solute. So when we define solute, solute is the substance that is being dissolved. Meanwhile, solvent is the substance that dissolves the solute. So in this case, we have the water. By the way, water is considered as the universal solvent because most of the substances can be dissolved by water. So going back, so we have the solute as the coffee grounds as the solute and the water as the solvent. So combining these two together, we have the solution, which is the coffee itself. Now, always remember that solutions are not just contained within the idea of a solid solute and a liquid solvent. It can also involve other phases of matter. So other examples of solutions can be first, okay, so soda or the soft drinks that we all know is made up of gases dissolved in the liquid. And it can be also be a solution of solids. So in this case, we have the alloy. So alloy is the term used for as the combination or the solution of two different metals. And lastly, we have the air itself. So the air is a mixture of different gases. Now, let us go to the heterogeneous mixtures. Now, heterogeneous mixtures are also known as suspension, simply because the particles are suspended with each component. So simply because that its particles are not uniform in terms of its distribution and appearance, therefore its particles are too large to be seen. Actually, most of the food that we all know are known as suspension. So even from the cereal that we eat to the salads that we tend to have in our kitchen, and also to the different materials that can be found within the environment. So such as the muddy water when it's raining and the polluted atmosphere or the smog that creates every morning. But think about this one. So, is milk considered a homogeneous or a heterogeneous mixture? Now, milk is a special condition or is a special type of mixture which is what we call as colloids. When we define colloids, so colloids are mixtures whose particles are larger than a solution but smaller than a suspension. So, it is in between a homogeneous and heterogeneous mixtures. And lastly, particles are mixed evenly all throughout. So some examples of colloids includes gelatin, or maybe the mayonnaise, or marshmallows, or even on other substances such as the aerosol perfume cans that we use for our perfumes, and even gems and paint. Okay, so that concludes our episode for today. This is your Sir Dave saying keep safe and always have fun learning science at home. Goodbye!